Dear friends, you must be wondering what has happened to me. Uh, I am also wondering what has happened to me. What I have done possibly is to reduce the number of times I am coming in YouTube, but think about a program that I have to make because I cannot say I don't have a team, neither, as I have told you, not a YouTuber in the natural sense, nor I am using any gadgets, nor editors or anything. I am simply sitting and talking to you, sometimes showing some math, sometimes showing you some books. So that is what I am doing. So this Sunday evening, I decide maybe one should have some chit chat about mathematics. So I have been screening through some of the comments which I had in various videos. Many people ask me, how do you study mathematics? One has to study mathematics for JEE, one has to study mathematics for some other competitive examinations. Or if you're interested in mathematics, how to study mathematics as a subject. So let me tell you what I can answer and what I cannot answer. If you have seen my older video of how I learned maths, you have seen how uncommon and very unusual way I actually got into this game of doing mathematics. Possibly I don't deserve to be part of this mathematical community, an undeserved mathematician rather. So I rather would tell you about my experience and also tell you about the ways one you might try to approach it, because to me it is clear over the years that everybody has his or her individual way of doing mathematics. Please understand that there is no force at all on you to do mathematics. There is a lot of background force which comes in. Suppose you are doing engineering, that you have to be extremely good in mathematics. Yeah, doing some mathematics with a reasonably well is okay, because that allows you to understand certain modeling aspects in engineering or economics or physics or chemistry. But that you have to love mathematics like a mathematician may not be always required. Always choose your path. That is the important thing that I want to stress about kids, that uh, they have to choose their path. If you want to be a writer, please be a writer. It doesn't mean that if you have studied science in class 12, you really have to do something in science or engineering or medicine or something like that. No, not at all. You can be a writer, you could study history, whatever you think interests you. That's it. Uh, it, you have to make that. You can study uh, some languages or whatever, maybe psychology or whatever you think would interest you. So this is the key thing that I want to first stress for youngsters. Many people are worried about giving the JEE, the joint entrance examination. I worry what happens to these kids. Look, what happens to their childhood? What happens to their going out and playing games or having fun, talking to friends? They are always inside the books, trying to learn up tricks about scientific subjects and not never learning the science, never learning what science actually is, never learning why we need to do all these things, what is the use, how these ideas have come across, why they are here. So there are a lot of stories which are there behind everything. We are storytelling animals, and so it's very important to know those stories. But we don't seem to do that as a part of our education, and students are hard pressed working through them. And people say, okay, there's a huge amount of population, so one has to have exams to sort out, give somebody some facilities and others some lesser facilities. But I do not know. When I was a youngster, it was told that, you see, you have to either be an engineer or a medical professional, or you have to stand with a beggar's bowl. I was clearly told by one of my relatives that mathematics will fetch me a beggar's bowl. So I was so intent on studying mathematics that it might just fetch me a beggar's bowl. Never think like that about a subject. If you think that you are good in something, could be literature, you will never stand with a beggar's bowl. When you do good in something, you will never stand with a beggar's bowl. Now the question would be, among so many people, would everybody be good in something and so good that is it that really possible? I am not telling that it will happen for everybody, but can happen for a good number of people. And for India, that is not happening for a good number of people. We were told that, oh, you are going to study a general class, general subject. Mathematics is a general subject. I don't understand what is general subject, or it looks as if it is a general knowledge. Modern mathematics is not general knowledge, neither modern physics or chemistry or biology or even modern art sciences. They are not general knowledge. Everybody doesn't know modern mathematics. Go and ask anybody on the street whether he knows about group theory or the basis theorem of linear algebra. He doesn't know with high probability. How many people even know about the fascinations of chance, about studying probability? Sometimes you have to study mathematics preparing for an exam. How will you study that? Because there is a peril there that in the process of studying, in trying to solve problems and try to get a hand on solving more and more difficult problems, you lose the sight of what mathematics actually is. Mathematics is really not about just problem solving. It is also about understanding the idea behind the concepts. The conceptual clarity, the imagination is far more important than just problem solving. If you advise me, if you ask me to advise you about how to solve problems, I would never say, okay, take 10 integrals and try to solve integrals of the same type. The things that you have in books. My thing would be to take, say, 2 different or 3 different problems, each of different kind. So each allows you to think very differently on the topics you have studied. So that way your thinking, your imagination improves, and that way your connection with mathematics deepens. So you have to deepen your connection with mathematics if you want to use it further in your life. Because what happens, if you do mathematics under tension, you never connect with mathematics. Mathematics is never about speed, it is all about being deep, trying to see why things are fitting in, why you have taken this approach. Even if you have used a trick, who invented that trick? How does that trick even come into your mind? So in these problems of JEE and other competitive examinations, you have to use this trick to solve this problem. So how do you even think of that trick? Maybe I can sit with that problem for whole day, do trial and error, and couldn't think of the trick. And then somebody else tells you that, okay, this is the trick, and then the problem gets solved in 2 minutes. So whose thinking was better? The kid who was struggling and making trial and error in various ways to solve the problem but couldn't, or the child who has been taught with a lot of tricks and he figured out two, three tricks he applied and one of the tricks worked. I would go to the former child who spent whole day hanging around with the problem, trying it in many ways but couldn't. He actually tried to open up paths or in focus a light on possible paths to the solution. I strongly back such efforts in comparison to somebody being just fed with tricks, which usually do when you prepare for competitive examinations, and then use some trick to solve the problem. You will never know what the problem really is. Why you have to solve such a problem? And if you are left alone, I'm sure that no tricks are taught. And if you take a difficult problem from a competitive exam like the joint entrance examinations of IITs, you just give it to me right away. I'll be sitting like a fool possibly. And I claim to have a degree in mathematics, a PhD degree. And should my degree be thrown away? Then all the research work that I've done in my whole life is of no meaning just because I couldn't solve a problem. The answer is no. Because we somehow do not teach our kids what mathematics is. So that is what I want to basically end today's discussion, keeping it a little open ended, and whatever you can take from the discussion will be your own way of interpreting what I said. Many people may not agree with me, but I also request those who want to comment against what I said, please be kind when you comment. Even if you don't agree, please be kind in your disagreement. And not make statements or send emails, which are very rude and very saddening kind of thing that, okay, what the hell, blah, blah stuff and kind of. Even at this age, I still would consider that there's so many things to learn and I possibly haven't learned anything. What I know, I wouldn't consider myself at all having any real knowledge. And I just have tried to enjoy mathematics out of a love for it. A love I developed because of a teacher in class 8, because before that I was just failing in mathematics. So I would just show you a book today written by a young mathematician in the US, Eugenia Cheng. One of the first books she wrote was How to Bake a Pie. She's an expert in some arcane subject of mathematics, as one might call it, called category theory. Many of you might not even heard of what is category theory, a very important part of pure mathematics though. So this is a book called The Joy of Abstraction, an exploration of math, category theory and life. I have had this book since maybe 1.5 years. So for the last 2-3 days I've just picked it up and just tried to look at it. It's a very nice way which shows you step by step how to think in mathematics. College libraries would do very well who has mathematics courses, especially with mathematics, who has an honors degree in mathematics, to have this book so their students can go and have a reading as to how to step by step think about mathematics. So it's published by Cambridge University Press, and here I just want to read a very small paragraph which she has written about what is math. So here I read from this chapter 2, Abstraction. What is math? Math is not just the study of numbers, equations, and it's not all about solving problems. Those are some aspects of math, and they are often the aspects that are emphasized in school math and the math for non-mathematicians. This is the point I want to emphasize. Because what happens in school mathematics, you are so obsessed with problem solving, and especially because you have to give competitive examinations, you do not really understand the reason behind your actions. And when you come to, suppose you get into IITs or some other good institutions, and when the real thing has been started to unfold, and when the real reasons, when reason becomes important as to why some things are done, then you find it difficult to understand, because you are never asked to reason in mathematics. Okay, this is the problem, there is a formula, solve it. Why that formula? Who gave us that formula? Why in the air? Who could think of such things? The whole point is that you should ask this questioning, because asking a question is the most fundamental activity in scientific thinking or mathematical thinking. Without any a question, if a curious mind didn't ask a question, how would we know so many things about a subject? We know that, okay, we do not know things, we are ignorant, so we ask why this thing must have happened, and then try to figure it out. So that is the point that she is also stressing here. Math in school tends to start with numbers and arithmetic, moves on to equations, and then maybe deals with things like trigonometry and a bit of geometry. Trigonometry and geometry aren't really about numbers but about shapes. As I told in my earlier video on how I learned math, as that my route to numbers had been through shapes. It was geometry which brought me to mathematics. So for me, mathematics is about visualization, about imagination first. However, they still involve a lot of numbers and things like calculating angles and lengths expressed in numbers. Math, as used in the world, does involve quite a bit of solving problems using numbers and equation. There are usually some measurable quantities measured in numbers and some equations relating them. The task is to calculate the ones we don't know and the ones we can measure. At least this is the most visible and obvious way in which math is used in the world. So I don't blame anyone for thinking that that's all there is to math. So you ask anybody, any person, oh, maths, it's a first year engineering, that's where math ends. Class 12 math ends. After that, there is no math. But when the people who say that do not know that when you hold your mobile and when you see things happening in your mobile, a lot of fascinating modern mathematics is happening here, starting from Fourier analysis, harmonic analysis, convex optimization, and all kinds of stuff, image processing. So all kinds of very good mathematics is actually happening here when you're using a mobile, modern mobile. So people think that the whole mathematical game ends there, but it doesn't. So this is what she says. At least this is the most visible and obvious way in which math is used in the world. So I don't blame anyone for thinking that's all there is. But there is more going on behind that. The theory of how those things work. So if those theories of how those things work were not known, this huge ton of metals which fly in the air called aeroplanes wouldn't be flying. When we fly in the air, we don't even think anything nowadays. We don't even think about the technology or the amount of the type of materials that is used and the amount of huge amount of complex mathematics that has been used to make that plane fly. So mathematics is at the heart of all these things, and those are the mathematics you don't study at school or in first year classes, right? So this idea that math ends there is a very common thing, and many people have told me that. Sorry, I would like to keep this in English, that or maybe a line in Hindi. मैंने आप क्या मैथमेटिक्स है क्लास 12 के बाद? What mathematics after class 12? What are you going to teach? Khatam, mathematics is finished. But the whole idea is so grossly mistaken. So that is why when you study mathematics as a subject, people wonder at you in India. Mathematics as a subject? Obviously, I'm not talking about people who are into science or mathematics or engineering. I'm not talking about them. But even educated people in many fields, mathematics as a subject. maybe physics would have been still meaningful. Chemistry would do, we would say. Mathematics as a subject. What on earth are you going to do with that? Who will give you a job? But nowadays, mathematics is playing a major role in the job market, whether it is finance, whether it is analytics, whether it is computer science. Many places they need mathematicians nowadays. Here in IIT, as this job season goes on, the mathematics department has a very good job ranking. People from mathematics background are sought after. So here she says again, but there is more going on behind that. The theory of how these things work, that theory which enables us to make sure they work, to refine them and to develop new versions to deal with more complex and nuanced situations. This is like the foundation of a building. You can't see them, but without them, the building doesn't stand up. So, here is a more philosophical aspect of mathematics, and we will end with this. Every academic discipline provides a way of reaching truths of some form. Every discipline is seeking a particular type of truth and develops a method or framework for deciding what counts for truth. In the era of information access, I think understanding of those methods and frameworks is far more important than knowing the truths themselves. Important thing is to know how to decide what should count as true, how to build good foundations on which to base our understanding. I strongly believe that this understanding of process and framework is what is most transferable about studying any subject, especially math. So you may just use a mathematical formula somewhere, and you just do not know why it has come. It has come from somewhere, right? Somebody has figured it out. Why that's some. These are the relations between these variables, and so or something else. So, for example, if you tell a normal people about groups or rings or fields, or if you talk about vector spaces, people are not very pleased. They think that they are not helpful in their day to day lives. In a normal world, normal setup, people are only bothered about the math that is used in day to day life. Calculus somehow has got into the popular mindset that calculus is doing some many things in this world. They are not sure whether linear algebra is doing so, or optimization is doing so, or statistics is doing so. People look at data collections, but people are not really bothered about how statisticians bring out certain information from the data. So people just listen to the end information. That is what she is trying to say, that just knowing the end information is not enough. It is very important to know how did someone reach those conclusions. So because that would allow you to develop your own intuitions about problems when you tackle them in the future. I don't expect everyone who is a part of this, uh, my subscribers or anyone who observe it, looking at this, my videos, would really want to be a mathematician. Will I call myself a mathematician? No, I would be more happier to call myself still a student of mathematics. Still, I am learning a lot of things. I am writing some papers, maybe some interesting papers, doesn't mean, or publishing in some very reputed journals, doesn't mean that I have really become a mathematician. I do not know when will one can I ever call myself a mathematician, because I have seen some mathematicians of great repute and of great capabilities. Recently, one mathematician from Mumbai, very renowned, Professor Nadkarni, he wrote to me that he liked my channel, and I was very pleased. And it was a kind of, this is a kind of, I want to mention that this is a great honor for me that such a reputed mathematician, such an honorable man, had seen my videos and have liked them. So that is what I want to tell the students, that choose a subject you want to read. Mathematics may not be one of them. If you at all choose to study mathematics as a subject, then I would really have to talk to you in a separate way. I will make a video for those studying mathematics as a subject. and what they should concentrate on. Because once you get into mathematics as a subject, then your likings will come within that. So that is you come into a world which is a mathematical world. And in the mathematical world, everything finally you might not end up liking everything. You might like most of them, but something will attract your attention more. So how to choose that and how to go there, maybe we can have some chat on that. And those who want to use mathematics as a tool, please, even you, when you want to use the tools, just knowing the formula is okay, but knowing something more about it is still better. So you can say, okay, you use this mobile. Do you know anything what is inside it? Yes, I don't know it. It's so complex that I do not know it. So if something is very complex, I don't expect you to go and hit around that. But if something is simpler, you can have some idea. I can at least, so this is, for me, it's an operational thing. So many people think those who use mathematics as an operational thing. But using a mobile and using a mathematical idea in applications like in physics or chemistry is not the same thing. Please remember this very clearly, that they are not the same thing, because you are going to use it over and over and over and again, and from there you are going to make a conclusion. Suppose you picked up a formula from a paper, research paper, you are doing a research. You have not read whether how that formula came, and you just use it and you got a conclusion. After 5 years, you come to know that that result was actually wrong, there was a mistake in their calculation. Then all your subsequent calculations are wrong. That is why verification is one of the most important thing. This is a part of the scientific method. And that is why I am telling that even if you use a formula, unless it is already a well settled formula, please, even if it is well settled, please know something more about it. That is what I would say to people who use mathematics as a tool. So anyway, we had a lot of chat on this Sunday evening. Maybe I'll come to you back with a new book which have just come in my hands, a beautiful one by one of my all-time favorite mathematical writers, because of my own fascination for probability theory. The Art of Uncertainty: How to Navigate Chance, Ignorance, Risk and Luck, by David Spiegelhalter. And I would say more about this book as soon as I can, because I said that every program will have some little book chat also. So you know these two books today, Joy of Abstraction by Eugenia Cheng and this one, but we will have more discussion on both these books later on. So let me say a goodbye and hope you have fun and enjoy your time, and those who would be giving competitive examinations, and for them, please don't get overwhelmed. If you find doing math is too pressurizing, relax yourself, go out, see movies. 24 hours of study might not always do things well. I have seen situations like that. So my experience said that if you feel too much pressure, leave it for some time and then do something else. Come back later on. I understand that people, you have to practice and practice and practice, and there is a old saying that practice makes a man perfect, and math cannot be learned without problem solving. Yes, it cannot be learned without problem solving, but it cannot be learned without understanding the ideas behind those formulas that you use. So thank you very much, and wishing you all the best. I say a goodbye. Thank you.